16, there was a video, 22 and 23, I kind of typed it on the discussion board. So now what we're going to do, we're talking about complex numbers, and before we do example number 4, I guess I should talk about conjugates. So conjugates, and you'll want to write this down in your notes because this is important. If I have a complex number, a plus bi, right? So this is a complex number. Right? Where this is the real element and this is the imaginary component. There is, for every real number, there is what we call a conjugate. So now the conjugate, and you got to really pay attention, because if you don't pay attention, it can be very confusing. The conjugate would be A minus BI. Does that make sense? So let me. What I'm gonna do is I'm gonna write down some complex numbers, and then we'll have some fun and write down some conjugates. So on this column, I'm gonna write down the complex number, and then I'm gonna write down its corresponding conjugate. And you got to make sure you have your thinking caps on today. If I have 7 plus 3i, what would the conjugate be? And no, 7 minus 3i. Okay, if I say 5 minus 5i, what will my conjugate be? 5 plus 5i. If I say 2 minus the square root of 3i, what will my conjugate be? 2 plus 3i. Now, really, the only thing that changes in the conjugate is this this sign. Yeah. Do you have a question?
I really can't see it. Can you like turn off the light or something?
Oh yeah, is the sun shining real bright? Yeah, turn off the lights a little bit. Let me adjust this. So the only thing we're doing is whatever sign I have in between my real and imaginary part of the complex number, I just switch it. So if it starts with a positive or a plus sign, then I switch it to a minus sign. Minus sign becomes a plus sign. Minus sign becomes a plus sign. So now I'm going to write this really complicated one. Ready? 5 minus the square root of 7 plus 6 minus the square root of 3i. Now what I'm going to do is nothing changes with regards to the real or imaginary portion of the complex number. The only thing that I'm going to change, is the sign in between the real and the real and imaginary. So here we have the real portion of the complex number, and here we have the imaginary. And nothing changes. Not a single thing changes here or here. Not a single thing changes between here and here. The only thing that changes is right in here. So what do I put there? Minus sign. Does that make sense?
Yeah.
Alright, so now to do example number 4, we need to use a conjugate. So example number 4 gives us a problem that says (2 minus 3 minus I). So 2 over 3 minus I. Now here's the thing. Remember that I is equal to the square root of -1, right? Can we have a square root on the bottom of a fraction? Can't do it. So I've got to move that square root up to the top. So the way that I do that is I multiply by this conjugate. So I'm going to take this and multiply it by 3 plus I. And remember, whatever you do on the bottom of the fraction, you have to do to the top. And so I have 3 plus I on the top. Now this is a difference of squares. So if I have A plus B times A minus B, it's always going to equal A squared minus B squared. In other words, on the bottom of this fraction, I'm going to have 3 squared, which is 9, and then I'm going to have minus I squared. But remember that I squared is equal to -1. So this becomes a positive 1, right? So this right here is actually 3 squared minus I squared, and then that becomes 9 plus 1. Is that right? Then on the top, I've got 2 times the quantity 3 plus I. Well, on the bottom I'm going to have 10. On the top I'm going to have 2 times 3, which is 6. And then if I push the 2 through to the imaginary part, I've got 2I. And you might say, well, that's kind of cool, but it's confusing. And by the way, the textbook said it wanted it in standard form. So standard form for a complex number is A plus BI. So if I have 6 plus 2I all over 10, that's not quite good enough. So what I need to do is I need to separate that. I'm going to say 6 over 10 plus 2I over 10. Right? We could do that. Well, I could reduce the fractions. This becomes 3 over 5 plus 1 over 5 times I. And that's how, that's the best way to write the answer. God bless you. Any questions on that one? Let's do one more just for good measure. For part B, they say, all right, you guys think you're smart. Let's see what you do with this rational expression. Ironically, this is a rational complex expression. So I can't have a square root in the bottom, and I is the square root of -1, so what do I need to do? Hit it with a conjugate. So I'm going to say 2 plus 3i times the stuff down here. And remember, whatever I multiply the bottom by, I also have to multiply the top by. And this is where it gets a little tricky. Well, the bottom is going to be 2 squared, and I'll write it out so you guys can see it, minus 3i squared all over the stuff up on the top. Well, here's the thing though. I'm going to have 5. Let's draw our little grids. So I'm going to have, oops, I drew one too many lines. I'm going to have 5i times the quantity 2, 3i. So 5 times 2 is 10. This becomes 2i. This becomes 15i. And then this becomes 3i squared. But I squared is what? So this becomes -3, right? So then this whole answer is going to be, now here's something that you don't get to do very often. 10 minus 3 is 7, and then 15 plus 2 is 17. So my top, my numerator, is going to be 7 plus 17i. So on the next line, if I come down one more line, I've got 7 plus 17i all over 4 minus 9 times I squared, right? But what's I squared? -1. So this becomes a positive 9. So I've really got 7 plus 17i all over 13, right? So now if I split that up, I've got 7 over 13 plus 17 over 13i, and that is the final answer. Does that make sense? Okay, good, good.